slightly longer presentation from a company that XFi has already invested in. It's a company that we know very well, and we're really proud to share with you as well. It's a company called BeyondMath. I love it because we have one of my hiring managers from Google who has started it up, Alan Patterson, and he is co-founding with Darren Garvey, who we have here today to present it to you. And this rounds out our part one today. This is an AI company, AI for engineering design. Longer form presentation, of course, so a little bit more in depth, but really interesting. I hope you enjoy it. BeyondMath, and this is Darren Garvey.
Thanks for the intro, Jenny. So we're BeyondMath. We're a relatively young startup, about 1.5 years old, and we're applying artificial intelligence to simulating the physical world. For decades, engineers have used numerical methods based on calculus to solve our most complex systems of equations. These equations are used to calculate and predict how our designs behave in the real world. They're essential tools for every engineer. They're essential for every single thing that we build. You might have seen simulations like this one. In aerodynamics, we can calculate the velocity, the surface pressures, and the turbulence of airflow over our cars and our planes. The simulations like this are used everywhere. They're used in automotive and aerospace, in energy and climate, in heating and cooling, building control, and many other areas. But they have a severe limitation. To simulate just 100 milliseconds of real time takes a supercomputer hours or even days to run. The ultimate supercomputing application today. They're expensive in time, in energy, and in computing power. This is a quote from Rob Smedley in Formula One. I think he was working on reducing the turbulence of two cars as they race close together. He said that they managed to get the first iteration of a two-car simulation down to 11.5 hours. And I think he's boasting here, because he's really talking about moving from supercomputers to the cloud. But it still took 7,000 cores running in the cloud for this simulation. It's these limitations which force our engineers to make explicit trade-offs between how many simulations they can run and how well they can design. Engineers can only afford to optimize a small percentage of any given problem. At BeyondMath, we're removing these constraints. We're using artificial intelligence to solve these equations orders of magnitude faster. We're already seeing speed-ups of up to 10,000 times faster. So simulations that today take hours or days to run can now take minutes or even seconds to run. Optimization typically takes thousands of iterations. And now, with this kind of technology, we can, instead of running just a handful of simulations, we can now run thousands of them. We can afford to optimize a much larger percentage of the problem. So a bit about what we're doing more concretely. We're on a journey to digitize engineering. Our very first product is the digital wind tunnel. We're working with one of the big Formula One teams. They're helping us fine-tune, develop, and validate the technology. In Formula One, they have a big problem with simulation. In order to understand the performance of their cars, they need to run a huge number of simulations. These simulations are incredibly expensive. The average Formula One team buys a $50 million supercomputer just to run their simulations. Most of them even build their own wind tunnels to validate them. And they cost $60 million to build and over $1 million per year to run. The sport aims to phase out the use of wind tunnels to reach net zero by 2030, but currently they don't have any practical path to get there. In Formula One, the teams are constantly iterating the design of their car. They bring effectively a brand new car to every single race and they set it up for the configuration of each race, the conditions of each race. What they need to do is run simulations across thousands of different setup parameters, but they can't afford to do that. All they can do is run just a handful of simulations and then guess at the performance for the other setups. What that means is they don't always get it right. They'd love to be able to fully map out the performance of their car, and that's where BeyondMath step in. With our digital wind tunnel, a designer is able to upload the CAD model of their car and see the aerodynamic velocities and the surface pressures be calculated in near real time. Here you can see what it looks like, one version of the wind tunnel. We have a Formula One car, and we're focusing on the front wing here. The streamlines here are showing the shape of the airflow as it interacts with the front wing. The colors represent the velocity of the air. You can also see the flap on the wing changing angles and instantly how that's impacting the shape and the speed of the airflow. In conventional tools, each change of this flap angle would be a completely new simulation. And in this case, a single simulation would take 10 hours to run. This video is not sped up. This is the calculations being done in real time. So would you rather wait 10 hours or get instant feedback? So to put numbers on this, earlier this year, we ran a validation study with the team. We took a 2D front wing, and in the conventional tools, the simulation took 100 CPU hours to run. In BeyondMath's tool, the same thing took 43 seconds. So that's 100 hours versus 43 seconds. It's 8,300 times faster. And the results correlated incredibly well with the previous simulations. So for the teams, this is transformational, because finally it gives them the option to fully map out the performance of their car prior to every race. Their engineer told us that this is game-changing. Teams spend millions of dollars just to get a fraction of a second speed up. So we believe strongly that BeyondMath's AI technology is going to transform mobility. This is not just about motorsport. We're already seeing potential improvements in aerospace, and we're looking into energy, specifically as a starting point with hydrogen fuel injection. So faster simulation translates to faster time to market. More simulation translates to better optimization. More accurate simulation translates to less physical testing. So maybe we do have a path to phase out the use of wind tunnels and digitize engineering. We raised a pre-seed of 1.5 million last year with XFi as an investor. We are right now, this month, getting together a pitch deck for a seed raise. And we're planning on kicking off discussions relatively soon for that. So if you're interested, please reach out. We'd love to chat. Thank you.
Fantastic. Thank you, Darren. They were amazing slides. Look at the artwork in there. People were commenting all the way through. That was very, very cool. So Alex Balanki asks, I wonder, what does it take to create such a deck? Serious question. How did you do that? Did you have a third party?
Well, our lead investor at Partners, they actually remarkably have a marketing team. So they helped us out with it, which is very gracious of them. And
amazing.
It's not our skill. We're engineers.
outsource. Gerhard Vesp, who I remember well from Google, he's plus oneing Steph, and basically saying, please quantify the accuracy of the AI approach versus classical. Also, how certain are you that the Formula One teams use the best possible classical algos?
Both good questions. I mean, I'd say Formula One teams are seen as some of the heaviest users of CFD in the world. That's why we work with them. We're kind of working with the best in the world on the hardest problems. And the main reason that if we can work for them and validate, get beyond what their threshold is, then it should work very, very well for all of automotive and a lot of the similar use cases.
It's a good one to start with, yeah.
Yeah, and in terms of quantifying the accuracy. So there's various measures. One measure is measuring effectively the coefficient of pressures on the surfaces. So if you're doing planes, it's lift and drag, and then the center of pressure, they're very important. So we kind of do statistical measures compared to that. And then there's another aspect of it, which is really around, is it better or worse, right? If people are making changes to a design, are they going in the right direction? And that's another much easier measurement because it's binary.
Yeah, absolutely. Fantastic. Quick question there from Frederick Leichner, who I worked with before as well. Hi, Frederick. He's basically saying, can you expand on the commercial model? How are you going to make the money?
It's really around simulations. So we're building a platform where people can actually run the simulations through us. Now, there's an accepted cost for those simulations. A huge portion of that cost is down to the amount of compute that's used. Now, we don't have anything like the same amount of compute, but it's an accepted cost for the simulations today. So at least for the early part of our development, we're going to be using those effective costs and just having much higher margins. It's a per simulation cost.
That makes sense. Thank you, Darren. That was wonderful. We'll obviously send across any details so that people can get in touch and learn more.
Thanks a lot.